balls. Now, what is the puzzle? That you have put these balls on thermocol plate. It's very easy, but the trick is you have to put these balls on the lower side, and
উপরে আছে
it is also easy.
ছাদে ছাদে ঘরে ঘরে কি করছে বসে আছে হ্যাঁ বলে যে কি করছে নিচে এসে বসুক না
সমরদা
হ্যাঁ শুনছি
মিউট করতে হবে আপনারটা
হ্যাঁ মিউট করছি সরি
ওকে ওকে
Thank you, sir. Acha. Now, again, it is very easy that you can drop it in the lower side, but the special trick is you can't upside down. You hold it like this, and the balls are in the lower side. How can it possible? Because in the gravity action, they can fall down. This is the trick. Now I have another camera. I'm switching to that camera and show the experiment. Yes, you all see this. Now I'm putting the balls here. Okay. Here are some other balls. Now I am holding the plate you see gravity is not working here.
Good evening.
What is the magic?
Wonderful.
Isn't that fascinating, children?
Yes, ma'am.
Yes, ma'am.
Yes,
Now
ma'am.
you want to learn the trick.
Yes, sir. Yes, sir.
Okay, now it is very simple. I am
Sir,
using my sweater.
Sir, it is electrostatic
Okay.
force. Yes, sir.
Yeah, you are right. It is electrostatic force. Now, see what happens. I am using another thermocol ball, a thermocol dish, and rub it with sweater. Yeah, you see, this is my sweater, and I rub it like this. And when I put the ball here, it goes down. No, it is not working. Today's humidity is very high. Now it is working. Okay, now I'm doing another experiment. There is a plastic glass and we fixed 4 straw on it. Now I am rubbing one straw with my sweater and bring it close to it.
দেখ 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 কিছু
Do you understand that it repels each other? I'm not touching it.
So is it attracting or repelling?
It is repelling, but not so clear. I am using thermocol stick and see what happens. Oh,
very good, very good.
no, it attracts.
Wonderful.
বাহ বাহ
No, I'm changing it and see what happens to this. It is also a plastic glass, but I put aluminum foil here and one gap, another and another. There is three strips of aluminum foil.
very good, very good.
Yeah. Try to rotate.
Done. Very good.
কৈকত ওই ঘষাটা একবার দেখা।
Yeah, this is my sweater and I am rubbing like this. Yeah. In this
Excuse me,
way.
sir. Next
Yeah.
question.
Yes,
Sir,
please.
you said that it will repel, but it is attracting.
I'm coming that. You just very carefully watch what happens. Then when I explain everything. Now I have a, let's see. What happens?
Sir, it is attracting.
It is
Attract.
attracting, right?
Attract.
Yeah, it is attracting.
Well done. Well done.
Now, what is the cause of this attraction and sometimes repulsion? What is the cause of it? You told me.
Sir, one body gets charged negatively whereas another gets charged positively. So it attracts.
Yeah, it is a electrostatic force. Okay. Now I'm sharing something. You can see. I'm stop camera. My camera. Now this is static electricity. And it produces when two different materials are rubbed each other. Now there is an important factor. There are two different materials, not the same materials. It is two different materials. Now why? Why? Let's explain. Now to explain this, you all know that the structure of atom. Now atom is consists of three particles. The positively charged proton, neutron, and negatively charged electron. Now in nucleus, the protons are bound; they can't move, but the electrons are moving around the nucleus, and they can move from one atom to another. Now everything contains charge. You see, everything contains charge. There is positive charge and negative charge, but normally everything is neutral. Why? Can you tell me why?
Standard
Anyone?
8 try. Standard 8 try.
Okay, okay. Now everything consists of
So
atom.
maybe the number of neutral, the number of positive charge and the number of negative charge is same.
So positive and negative together
Yeah,
makes it neutral.
you are right. That number of positive charge, that is proton, and number of negative charge, that is electron, are same, exactly same. You see here that all the everything, they have exactly equal number of protons and electrons. So normally everything is neutral. So the total positive charge and the total negative charge neutralize each other. Now, um, if we rub two materials, now the force of nucleus on the electrons are different for different materials. There are different atoms. So when two different materials are rubbing each other, sometimes from one material to other, the electrons can flow, electrons can transfer, and which one is collecting electron and which one losing electrons, that depends on a electrostatic series. Here you see a list of materials, and when we choose any two materials, the upper one becomes positively charged and the lower one is negatively charged. Now mm, let's see when two materials are rub each other, what happens. Now this is a fate simulation, and here in the sweater you see that there are equal number of protons and electrons. In balloon and the wall all are same, so they are electrically neutral. Now if we rub the balloon with sweater, what happens?
Sir, the electrons of the sweater transfers into the balloon.
Yeah, you are right, absolutely right. Now see, the sweater loses electrons and exactly the same electrons goes to the balloon, and you see that the electrons goes to the exactly same part of the balloon. No, it does not goes to the upper end. Now, if we show here is a positively charged and balloon, and this side of balloon is negatively charged, so they attract each other. But when the balloon touch with the wall, what happens? Now you see that this negatively charged electrons repel that negatively charged electrons in the wall, so it goes to the right side. This is called induction, induced charged. So we see that there are two types of charges, and it produce exactly equal amount.
হ্যাঁ কল
Now,
করে ও আচ্ছা আচ্ছা করে
now this method of charging objects involve rubbing. Now, in this process, which one is transferred, proton or electron?
Sir, electrons.
Right, electrons, and one substance will gain electrons, becomes
Sir, negatively charged.
Negatively
yeah,
charged.
negatively charged,
Charged.
and the other one is positively charged.
The positive.
Yeah, and they attract each other. Okay, okay. Now here we take only non-conducting materials. Why? If we take conducting materials like aluminum, like copper, what happens?
So then it will repel.
Mm, is there a charge?
Sir,
Why,
in
why,
conducting materials, there are free flowing electrons.
good, yes. So the after rubbing, the electrons can flow from one part to another part. So this is called static electricity. When we are using a non-conducting material, the electron or charge produced remains same at the remains static at the same position. Now looking into the history. In the ancient Egypt, uh, there they know about this magical fish. When they touch to this fish, they got shocked, and they can use it to cure headache also. They called it magical fish. They don't know why, but they called it magical fish. Now this is amber. Amber is a resin from trees, and they use it as a ornament also. And when this amber rubbed with cat skin, it got charged, and exactly the same of that fish. In Greek, amber means electron. And after that, you all know who is he? Do you know him?
Sir, Benjamin Frankenstein.
Yeah, he is Benjamin Franklin, and he gives the name positive and negative. The positive charge and negative charge, the name of positive charge and negative charge is given by Benjamin Franklin. Now, how we can examine whether a body has charged or not? How can we examine? Can you guess whether a body is charged or not? How can we examine?
Sir, when the body attracts the another body, then we can say that the body has been charged.
Mm, okay,
Sir,
but
if the body
yeah,
attracts or
but
repels, then
attraction or repulsion. But if we have a machine, oh, there is a network problem. Okay, now I am going to make an electroscope. Do you know
Sir,
what is
we couldn't
electroscope?
hear. Sir, we couldn't hear in between. How can we examine whether a body has charge or not? You were not audible then. Can you
Yeah,
say that again?
hmm. With a electroscope. It is a simple electroscope we are going to make. Now I'm stopping share here and on the camera. Other. Yeah. This is a electroscope. A simple electroscope.
Sir, your voice is echoing.
দুটো মাউথপিস চালানো হয়ে গেছে।
Oh. Is it clear? Okay.
Yes.
Now this is a simple electroscope, and you see here there is a aluminium foil leaf, and what happens when we rubbing the thermocol and place it near the top of it, can you see? The leaves are deflecting, you see that.
Nice, nice. Very good. আরেকবার বাহ
Clearly visible.
But I am not touching it in the oh.
Is that made
Now
of thermocol, sir?
no,
The rod?
this is thermocol.
Thermocol. Yeah. Okay.
Now do you want to learn how to make it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
Now for this uh, all you need a glass bottle like this or any other bottle, and even you can do it using a glass, simple glass. And this is one thing, a simple glass or glass bottle, aluminum foil, a piece of aluminum foil like this, and a piece of conducting wire, and scissor or needle like at first. mm, uh, I am going to make with this glass. Now put the glass on a pitchboard and mark the outline, and then cut it like this. Okay, this is the first part. And if you have the cap, so you don't need to cut the pitchboard. Next, using this aluminum foil, you fold it and draw a leaf like structure and cut it. So you get two foil at exactly the same size like this. Okay, now make a hole on the upper part Yeah, this is the second part. Now take the conducting wire and make a, bend it like a hook. Yeah, like this, like a hook, and hang the paper foil from this. You hang this, and after hanging, and uh, the circular pitchboard, the cut piece, you put the wire, make a hole at the center, and place it from the hole. So it becomes like this. Okay. Now you place it at the top of the glass and seal it with sellotape. Done. It is. Your electroscope is ready, and here I am using this bottle and not pitchboard. It has its own cap. Now I lock it. Yeah, this is the another electroscope. And
Sir, your video is stopped.
what?
না দেখা যাচ্ছে ও যে বলছে তার নেটওয়ার্কের প্রবলেম আছে। ক্যারি অন।
Okay. Now see how it works. You see this deflection?
Sir, the two aluminum foil leaves will repel or attract.
Yeah, two aluminum foil repel each other. Now,
Okay, sir.
with this electroscope, we can understand various things. You all make it at your home and examine many things. Now, let's start. Now, see, first, I am not touching. And place it near the top, and you see there is a deflection.
Yes, it can be
Yes, sir.
seen.
Yes, sir.
Yeah, Now
Yes.
I'm not touching, but still there is a deflection. Now why? This is called induction. That means the- I'm rubbing at the this portion of the thermocol stick, so it has charged. Suppose this is negatively charged, so it has more electrons. This negatively charged induce positive charged here in the top, and negative charge at the lower lip. So the two lips are negatively charged, so they repel each other. You see it? Now there is a more, yeah, it is more deflection. You see, and when I place it near it, it it deflects more, but when it goes further away, it becomes lower. Now I touch it.
Sir, if we place the positively charged area, then
Positively charged? I can't hear you.
sir, positively charged area like
I don't hear you.
See, if you, sir, if you keep your palm over it, then
See, now I'm there is still a deflection. Now I am touching it.
so is the attraction or repulsion when you put your hand?
There is no attraction or repulsion. The my hand is neutral and it is grounded. So when I touch it, all the charges goes to my hand and goes to the earth.
Not audible. You are not audible. Who is it? You are
Sound
not
is
audible.
breaking. Sound is breaking.
Your voice is breaking. Please stop talking. Your voice is breaking.
which is positively
No,
Who is it?
the sound is it's not clear. Okay, now I'm seeing another interesting thing.
Sir, I want to ask a
I'm
question whether it will be positively charged or negatively charged. How to know when you rub the material against something?
okay. Then we go to the electrostatic series.
Okay,
The two material in the series, which one is in the upper position, it is positively charged, and which one is the
okay,
lower position, it is negatively charged. And the wool is in the upper position, and thermocol is in the lower position. So thermocol is negatively charged.
okay. Thank you, sir.
Now uh, now I'm showing you another interesting thing. I'm holding this. Okay, another charge. Now I am touching with the thermocol and also with my hand. Now release simultaneously. You see, there is a deflection. Now, if now what happens to it? Now I'm again touch it. I'm doing the same thing again. You watch it carefully. I touch it. There is a lot of deflection. Now I touch with my hand. There is no deflection. Now I release it instantaneously. You see, there is a
Sir,
deflection. Yes.
sir, if you only touch with the hand,
If we only touch with my hand doesn't contain any charge, so it does not deflect anything. You see here, there is another electroscope, and if I touch it with my hand, there is no deflection. You see, there is no deflection.
yes, sir.
Sir, if you rub your
But
hand,
is it because our hand is neutral, that is why they are not getting
Yeah, yeah,
deflected?
yeah. So electroscope is the
sir, if you rub your
instrument.
hand and then touch,
Rub my hand with another thing. Another thing means with sweater or any other material, then it can deflect.
Sir,
Okay.
sir, could you rub your both hands and then try?
No, both hand with the same atom, with the same material. So same if there are the two materials are
Sir,
same. What
sir,
what I can't hear you.
you are not audible. Your voice is breaking. Sir, my question is that
Yes.
Sir, will
Okay.
it happen if we rub our both hands and then touch?
is
No.
that
It's not happen because both are the same material. So electrons can't goes to one to another. Now here you see that there is a deflection. Now if we place the same thermocol again, now see what happens. It's when becomes closed. You watch it.
Yes, sir, we can
There
see
is a
it.
initially there is a deflection. Oh, your sound is very much breaking. I can't
you
hear you.
will ask question in the chat box. Pooja ma'am will collect it. Please don't talk now because it's not
Okay,
audible.
okay. This is very interesting. You watch carefully. There is already a deflection. Now, if I place the thermocol close to it, the deflection goes. There is a still deflection, but when I place it, it goes. Now, why? To know that, we now we am going from the first. I am touching the head, so there is no charge. Initially, there is no deflection, so it has no charge. Now I am rubbing the thermocol stick with sweater, so it is negatively charged. In the thermocol, there is a more electrons. It is negatively charged. Now I am touching it. Now when I am touching it, it is positively charged and the negatively charged goes to the lower end. Now when I touch it, it goes down. Why it goes down? Because there is no charge. But it is not correct. There is charge. You see, when I release the both my hand and thermocol, it is still deflecting. Now why? To know that, when I touch it with negative charge, the induced charge, the charge induction is it induced the opposite charge at the near end and the same charge at the further end. So there is a negatively charged. It is negative charge at the lower end. Now when I touch it, this lower end charge, negative charge, goes to from my hand and goes down. So there is no negative charge. And the positive charge, it is bound charge. The negative charge is free charge and positive charge is bound charge. So bound charge does not go, and free charge goes to the earth. And when I release it, the bound charge is, as it is a conductor, so bound charge goes everywhere. So there is a deflection, and it is deflecting due to the same charge, that is negative charge. So when I uh, no, it is deflecting due to the positive charge. The positive charge is a bound charge. So there is a positive charge. So and when I induced the same thing, now it induced negative charge here. Initially it has positive charge. Now induced it negative charge. So it becomes closer. With this, you can understand what is bound charge and what is free charge. In case of induction, the it induced the opposite charge at the near end, and that is the bound charge, and the same charge at the further end, it is the free charge. Now I am showing you another experiment, another thing. It is called spike effect. Here the upper part is like a needle, it is like a spike. Okay, I am doing it another thing. Yeah, I have a aluminum ball and a needle like spike attached with it. Now I am pointing this needle to the upper portion of the electroscope, but not touching it. You see, I am not touching it. Now I am rubbing the thermocol stick and place it. You see the deflection?
Yes, sir.
I am not touching anything, but there is still deflection. Now I release it. The deflection remains. You see? Now how? Why there is a it it remains deflected? Because there is a charge. It accumulates charge. Now why it accumulates charge? Because of this needle action. When there is a spike, it discharge charges, and when this spike discharge charges, it accumulates on the head of the electroscope.
Sir, the ball is made up of what?
Aluminium.
Okay.
It is a conducting ball. There is a more deflection, you see, and like this way again.
Sir, the wire connected to the ball, that is also conductive.
What?
The wire connected to the ball is also conductive.
Yeah, it is a conducting wire. The needle is conducting wire, made of conducting wire. So from this you can understand that due to this needle action, the charge can discharge from easily with this needle. Now with this concept I am going to the next part.
সৈকত, বলছি যে লাস্ট এক্সপেরিমেন্টে একটা ইলাস্ট্রেশন দিলে ভালো হতো যে কেন ডিসচার্জ হচ্ছে, তো ওইটা ইনডিউস করে যে ডিসচার্জ হয়ে যাচ্ছে তার একটা এক্সপ্লেনেশন দিলে ওদের বুঝতে সুবিধা হতো। মানে ওরা দেখলো জিনিসটা ঘটছে কিন্তু পুরোপুরি বুঝতে পারলো না যে রয়ে গেল কেন চার্জটা, উপরটা কি করে ডিসচার্জ হলো। এটা একটু একটা ডায়াগ্রাম করে পরে করে দিও ওটাকে।
Yes sir, I will do that, but
কিন্তু খুব ভালো
charge density, it is the main factor. Okay sir, I'm now here is the topic, making of electroscope. We all do it next. Now you understand what is electrostatic induction and conduction. Induction means when we don't charge touch it, and conduction of charge means when we touch it. Now there is a bound charge and free charge. The near induced charge is bound charge, and the rarer charge of the further end charge is free charge. Now there is a problem. Now here is the thermocol stick. It is negatively charged, and the metal ball or the ball is neutral. It is same number of positive and negative. Now which one is the correct diagram? There are 4 options. A, the positive charge goes up and negative charge goes down. B, remains exactly same, it is oriented random wise. And C, the positive charge goes near to the thermocol stick and negative charge to the other end. And D, opposite situation, the negative charge goes to the near to the thermocol stick and positive charge to the other. Now which one is the correct? Can you tell me?
Sir, C.
Yes, you are right. It is C. Now it is C. Now from this can you tell me which one is bound charge? In the picture C, which one is bound charge? It is electrostatic induction. Now due to induction, which one is bound charge? It is positive or negative? this positive one or negative one. Which one is bound charge? If we touch the ball, if we touch the ball, then which charge remains same, and which one goes to the earth? Can you tell me? Okay, now I am repeating the same concept. Here the positive charge attracts negative charges. So as the thermocol stick, it has negative charge, it attracts this positive charge, and this positive charge is bound charge, it can't go to anywhere. And in the other end, this negative charge is free to move. So when we touch this ball, this negative charge goes to anywhere, but this positive charge remains same. It is bound charge. Okay, do you understand?
Is positive
Yeah.
charge always bound charge and electrons are always free charge?
No. No. Uh, if the thermocol stick is, in this case it is negatively charged, so this positive charge is bound charge. If this
Okay,
stick is positively charged, then there is negative charge induced opposite charge. See, this opposite charge is the bound charge.
okay.
After induction, the opposite charge is bound charge, and the same charge is free charge. Okay, now,
Okay, sir,
Can I
got
ask a
it.
question?
yeah.
What is the difference between free charge and bound charge?
Yeah, I'm going to the previous slide now. After induction, induced opposite charge at the nearer end. So these opposite charge attracts each other. So it is bound charge. It can't move to anywhere. But the same charge which produce at the further end, it can goes. When we touch it with a conductor, it can goes to anywhere. So it is free charge. Free means it is free to move, and bound means it is remains bounded. Okay.
And if the bound charge was negative and the further end charge was positive, would
Then
that positive charge be free charge?
yeah, positive
That
charge
will
will
move.
be, that will move. That will move means positive charge don't move, that electrons can come and neutralize them.
Okay.
Now here is the topic, the accumulation of charge in the cloud. Now there is a misconception that everywhere we have a concept that there is a friction between cloud to cloud. So there is a accumulation of charge, but here one is asking that if we rub to my hand, is there charge? There is no charge, because the our two hand remain at this, it is the same material. When we rub it, mm, the two atoms are same. So there is a no electron transfer. For electron transfer, the two materials must be different. So when clouds, there is a friction between clouds, the clouds are the same material. So there is a no transfer of electrons. Then why the accumulation of charge in the cloud? Now here there are many theories. Now in this picture you see that in the same cloud, the positive charge accumulates in the upper half, and the negative charge goes to the lower end. So there is a sparking between the cloud to cloud, that is from upper end, upper portion to the lower portion of another cloud, or from lower portion to ground, and the ground is for induction, it is positively charged. Now, how this charge is accumulated in the cloud? There are many theory, and the theories saying that there is a conduction current of air and water molecules, and when air goes up and water molecules goes down, there is a friction between air and water molecules, and at the same time when water molecules goes up and ice particle in cloud, there are teeniest ice particle, this ice particle goes down, there is a friction. You see here, the water particle goes up and the ice particle goes down, and due to this friction the water particle loses electrons and ice particle gain electrons. So the water particle, it is positively charged, and the positive charge accumulates at the upper end, and the ice particle, it accumulates electrons and goes down, and the lower part of the cloud is negatively charged. This is why the this is how the cloud goes charged. Now you see the spike effect, and next, that is lightning conductor. Now lightning conductor, it is a conducting wire or rod that is touched with the ground, and the upper end, it is like a spike, needle like. Now when there is a cloud and you see that the cloud has charge, it is positive charge at the upper end and the negative charge at the lower end. So what happens, there is a electrical induction. Yeah,
Yeah, please continue.
okay. Now there is a electrical induction, electrostatic induction on this lightning conductor, and due to induction, what type of charges induced in it, whether it is negative charge and positive charge to the lower, or positive charge to the up and negative charge to the lower. Which one is correct? Now here the lower end of the cloud is negatively charged, so this negative charge induced. So here the upper portion, there is a positive charge, and the lower end, it is a negative charge here. Now you see that this positive charge is bound charge, and this negative charge is free charge. What happens now, this negative charge is free charge, so, and it is grounded, so it goes to the ground, there is no negative charge here, and due to spike effect, this positive charge leaks, and there is a path where this positive charge goes to the cloud. Actually positive charge doesn't go, there is a electron which comes down to the conductor, and it is a continuous process, that is not lightning. Due to the induction, the potential difference goes down, and that is why the when lightning occurs, there is a huge potential difference, due to which lightning is occurred. But in the action of this spike effect, the induced charge leaks and the potential goes down, so there is a uh, no scope of lightning. In this way, uh, the possibility of lightning goes down. Do you understand the spike effect? In this way, it is works. Not like the this there is a spike lightning on this conductor and it goes down. It is not correct. Okay.
The negative charge in the cloud induces positive charge at the top end,
Yeah.
top of the, and because of the spike effect, it remains there.
No. Due to the spike effect, it discharges the positive charge.
So it discharges the positive charge and
Ah.
gets neutralized by the electrons from cloud.
Yeah, and the potential difference between the ground and cloud goes down in this way.
Okay. Okay.
So there is a lack of possibility of lightning. That is the main role of lightning conductor.
Okay.
Okay, sir, got it.
Okay, now do you have any question? I'm stop sharing.
Sir, I don't
Yeah.
have any question.
Okay, it is 7:30 now.
Sir, good evening. Two questions came up from two of our children. May I ask?
Yes.
First question is from Arulika. Arulika says that, sir, what is induced current?
Induced current, we are talking about static electricity. There is no current. Okay, induced current is another topic.
Oh, sorry, you said a word called induced or something.
Induction.
Yes, induction. Yes, I want to I want you to explain that.
Yeah. So what is it? It
Without
is
touching. Sir said without touching, that is induction. Between induction and conduction, you said the difference, and probably she is asking that.
okay. Induction means when a charged body placed near another body, the other body goes charged, and it is due to the induction. And when we touch it, it is due to conduction.
Okay, sir.
Okay. Next.
Sir, there is a question from Shoptorshi. Shoptorshi is saying that in this experiment, sir said that electric current will go to earth through our body. So will any footwear affect the process?
Any
Footwear.
Oh, no. Because it is very tiniest current. It is not a huge current. So our body, it is the amount of this current is so much small that current means e- electron goes or comes down, that the footwear does not work here. When it touch it, it goes. I'm wearing a footwear here, but it is still working. When there is a huge current, uh, if you using a tester in the to test the live wire, then there is effect of footwear there. But in this case, it is very much negligible effect. Today the humidity is very much high. I can't show you the magical portion of this electrostatic experiment.
Is it hot? Is it warm in Calcutta?
Yeah, and the humidity is so high.
Oh yes.
So I can't show you the uh, various experiment.
But you showed many
Yeah.
experiments, sir, and that is really fascinating.
No, I am not satisfied because There are
You can tell the
magical.
experiment. If you can tell which one you couldn't do, if we try it here, is it possible?
Uh, it, there are many things, man. That thermocol plate, it can floats when they are similar charge. When we I hold one plate and place the other plate in
Under the
upper, it floats.
okay, okay.
I can show that.
We may try here. If I shall contact you if we can try here and be successful.
Okay, and in this portion, the main concept is the bound charge, free charge, and the accumulation of charge in the cloud, and the spike effect, and the lightning conductor. All the children can understand that point.
Yes,
Yes.
sir.
Yes, sir.
Okay, okay.
One thing is when the clouds get charged, top part positive and lower part negative,
Yeah,
there is an exchange of electrons between the ground and the earth. Sorry, between the cloud and the earth.
yeah. There is a scope of lightning when the potential difference goes high.
Mhm.
So
Then
there is a scope of lightning.
and to stop that, we put lightning conductor.
Yeah,
Uh, and I'm just briefing it for the children. If I am wrong, please correct me. The lightning conductor, the spikes are on top. They get positively charged by the negative charge of the cloud gets induced positive charge, which is bound charge. And the opposite end means towards the earth, lightning conductor that is towards the earth, towards the ground becomes negatively charged. And that negative charge flows into the ground.
yeah.
Is it so?
It is. It is.
And because of the bound charge, because of the spike effect of the charge, this positive charge will be discharged and attract the electrons from the cloud,
Yeah, it is.
and so get neutralized by that.
Yes, that is why.
And thus prevents the lightning. Okay. Okay, I think.
Okay,
Thank you so much, sir. Thank you so much.
and
It is so difficult to show experiment this way. You know,
yeah.
choosing the right background so that we can see the deflection and all that. Thank you so much. You've taken so much trouble.
Okay.
Thank you, sir.
Very much.
Bharti
Thank you, sir.
Thank you, sir.
Yes,
Thank you,
yes,
sir.
ma'am. Principal ma'am.
Thank you, sir.
Thank you from our end. This thank you is that only on one condition, that you will come again and be with us, because it's so very interesting, and it was beyond my imagination. I'm not a science student, and it was beyond my imagination that these things can be done like this. Thank you so much, sir.
I'm
Please
sure
come
he will be
again.
more satisfied
No,
if we can bring him here in front of the children, because
That's it.
showing
yeah,
it through
it is
online.
more easier for me.
Yes.
Yes.
Yeah, online experiment is not suitable for me. And
I feel,
it is
sir,
very
you're not
difficult.
satisfied, and that's why people who become satisfied become stagnant, and that's why I could feel that you wanted to interact more, and you wanted to be more with the children, and that's excellent part of a teacher. That's very appreciable. Thank you so much, sir. Thank you, Shamos sir. Thank you, others who are present
Okay.
here. Thank you,
You,
children.
Samudra and
Thank you.
Birenda, both of you are
Virendra,
here.
sorry. Virendra, thank you so much. Virendra, yes, I did see him. I missed out. Virendra, thank you so much. Thank you so much. Shall we end the meeting,
Sir
sir?
guided me a lot.
Okay, yeah.